Welcome. In this video, I would like to recap some of the main points for the RFM analysis that we covered a couple of days ago. Let's cut to the chase and go directly to the implementation of RFM. RFM is very easy to implement, and we normally have two types of information about customers in our database. Who they are, the demographic information, and what they did, and what they do, the behavior information. Most of the cases, the behavioral information will beat the demographic information. The reason is that we care about demographic only to the extent that they can help us to predict the behavior. But if we have already have the behavioral information at the first place, those will be a much better predictors than the demographics on a much higher, much more aggregate level. And RFM on this dimension, it only rely on behavioral information of the customers. The downside is that because we can only use behavioral information, it can only be applied to existing customers. For new customers, when we don't have their behavioral information, we won't be able to apply this method. It is widely used and it's very easy to implement, no analytic team required, and you need very, very little statistical knowledge for implementing this method. It's widely used in B2C as well as B2B case, but of course there will be some small variation, and which we will talk about in more details next week. One last thing is that RFM is mainly about predicting the response rate. It has a much better accuracy in terms of predicting response rate, but it's not that accurate in terms of predicting profitability of a customer. So RFM, there's three factors: recency, frequency, and monetary. It's basically how long ago did the customer make the purchase from us, how often, and how much. The reason why we use these three measures, the heuristic reason, more intuitive reason to explain is that, well, these three factors indicate how much interest the customer has regarding our product. And so that's why we start to use these three at the first place. And then it just kind of work in practice, and then hence the name and were created, and people start to use it all the time. Of course, at your work, if you find there are some other variables that are more suitable than RFM, and so they have a much higher predictive power than these three variables, and you can use it on those variables instead of RFM. Okay, the basic idea of RFM, the reason why we want to use RFM is that we want to segment our customers into different groups. Then when we have a certain offer in our mind, we want to promote some particular product, and we want to target at those segments that with a high response rate for this particular offer. We don't want to waste the money of communication with the customer about this product on those segments that have a low response rate. And if in the extreme, if a segment has zero response rate, none of the member in that segment will buy. Communicating with them is a simply waste of the marketing money, and because there will be no revenue out of that segment. So the way that we segment the customers is quite simple, right? The first thing is that we pick a variable of interest. Let's just start with the recency. So we go to the whole database. We divide our customers and into 5 groups if we're using quintile analysis. If we divide them into 10 groups, we call it decile analysis. So basically, we rank our customer from the best customer to the worst customers, and into 5 groups, group them into 5 segments, and based on recency. And then we do the same thing for frequency. Rank my customers from the most often, most frequent customer to the least frequent customers, from best to worst, and then divide them into 5 groups. We do the same thing for monetary. So after this grouping, every customer has 3 numbers, and in which group and this customer belongs to as measured by recency, in which group this customer belongs to as measured by frequency, and in which group this customer is belonging to as measured by monetary. So, for example, if a customer has the group number 125, that means this customer is the best as measured by monetary, second best as measured by 125 means first best customer as measured by recency, second best as measured by frequency, worst customer as measured by monetary. If it's 55, that means this customer is the worst customer as measured on all three dimensions. In this case, if we're using quintile, if we consider all the combinations along all those three dimensions, and we'll have 5 times 5 times 5. That means there will be 125 different segments or cells of customers as measured by RFM. If we are using decimals, that means there will be 10 times 10 times 10. There will be 1,000 RFM segments. And what we will do next is we want to know which segment of customers they are more likely to respond to this particular offer. What we will do next is we will run a small test, okay, a test experimentation. So we'll make a random draw of customers from the whole database. And then we send this particular offer to this random sample to everybody, to every customer in this random sample. Okay. And because this sample is randomly drawn from the whole database, so this random sample, it will also have 125 RFM segments, the same as the whole database. And then for using this random sample, we can assess for each segment what is the approximated response rate for this particular offer. For example, for the group 1 to 5, and in this random sample, and we see there are 100 customers belongs to 1 to 5 in this random sample. 5 of them responded to this offer. So 1 to 5 group in this random sample have a 5% of response rate. Okay, and then for the whole database, because the random sample are randomly drawn, so I can also make the inference that for the whole database, whoever is belonging to 1 to 5, on average, this person has a 5% probability of responding to this offer. So, and then what we will next thing that we want to think about is that to which segment to target for the remaining customer for the whole database. Okay, and the idea is that I only want to send it to those customers who can make profit. I can make profit. I don't want to send the offer to those customers that has a very low response rate, and sending offer will basically wasting the money. So how do we find out which customer is to be on expectation will be profitable for this particular product, and which segment will be causing us losing money and for this particular offer? The way to think about this problem is that, well, suppose we know the response rate of a person, and we also know if this person make the purchase and what the profit margin will be, okay? And so we also know the cost for communicating with this customer regarding this offer, okay? If we put these three numbers together, so the probability of responding to this offer times the profit when this customer made the purchase, and that will give us the expected profit. And we need only if the expected profit is greater than the cost of sending out the offer, and we can generate some profit, right? So as a result, if we rearrange this equation, what we got here is basically cost over the profit. It will be the lowest response rate that we can get any profit, positive profit at all. Okay, so and to understand this break-even response rate, it basically means, well, if a group segment has a response rate higher than this break-even, by sending out this offer to them on expectation, I can make money. But if a particular segment has a response rate lower than that cutoff, lower than this break even, and if I send the offer to them on expectation, I will be losing money. Okay, so then what we will do is basically we know the response rates of all the segments in the remaining customer database based on our test on the random sample. So what we will do is I will pick those segments with a estimated response rate higher than this break even, send this offer to every one of them, and then forget all the remaining segments whose predicted response rate based on the random sample are lower than this break even. So how do we implement RFM? Let's use the book binder book club as an example. So this book club is more like a catalog type of company. So they send out book offers, promoted a particular book, and hope that the book club member will make the purchase of this book, and then they can generate some profit out of the purchase. Okay, so now they have what this company has is basically they have this particular offer and this particular book, and they want the customer to buy. The book they want to promote is called The Art History of Florence. Okay, and so they want to promote the book to those segments who are more likely to buy. So what they did first is that they made a random sample, made a random draw out of the whole database, and the random sample is 50,000 customers. And then they sent this offer to every one of these 50,000 customers, among which 4,522 of them, they responded, they bought the book. Okay, now we have information about the recency, frequency, and monetary for the whole database. And so now we want to know for the remaining customers, which is in the size of 500,000 customers, for the remaining customers that are not in this random sample, to whom I should target. And to do this, before we proceed, we want to make sure a few things. Okay, first thing at first, we want to make sure that customers, they're different for non-buyers and buyers. They should be different on RFM, these 3 dimensions. Okay, because if the buyers and the non-buyers, they are otherwise all identical on RFM, these 3 variables, okay, RFM pretty much, they have no predictive power for us, right? And so basically they cannot tell us which are more likely to be buyer, which are more likely to be non-buyers. Okay. The second thing that we want to check is whether these 3 measurements, they are independent from each other. And think about the extreme case. If RFM, they're perfectly correlated, we only need one of them. We don't need all 3. Okay. And so the third thing that I want to check, well, is how predictive they are for RFM. These 3 variables when it comes to the likelihood of purchase this particular offer. Okay, and we'll come to explain this last point with more details in a moment. And then, of course, there will be then we'll talk about how to implement in data. Okay, and first thing first, let's check whether buyers and the non-buyers, they are different on RFM, these 3 measurements. To do so, I want to calculate, did a simple test just to compare the means of RFM across the group of non-buyers, across a group of buyers. So among the 50,000 customers in my random sample, 4,522 they bought the book, and the remaining they didn't buy. And across these 2 groups of customers, buyers and non-buyers, and they are all different on RFM. Last is the variable to measure recency. Perch is the variable in the data set that measure frequency. Total is the variable in the data set that measures the monetary. Okay, And you can see here, right? And so the person, the buyers on all dimensions, on all three dimensions, they're better customers than the non-buyers. So they bought more recently and they make more purchases and they spent more. Now let's check whether these three measurements, they are independent from each other. Okay, and so last has no correlation with purge, and zero correlation with total, and it's almost zero and insignificant. So as a result, we can conclude that last and purge and total, they are not correlated. So by having all three there, each one of them, they will bring in some new information about which customer is more likely to buy. Okay, and so there's one thing that we need to see is that it seems that the purge and the total, they have some correlation, 0.5153. Okay, it's also significant, right? Here we need to make a judgmental call, okay, and well, whether we should have both there or we only need one. Okay. First of all, for the purpose of the demonstration of this method, I will proceed to include all three. Okay. In practice, 0.5 is still a relatively low correlation. So it means, well, having both there and each one of them, they will provide some new information about which customer is more likely to buy. But you have to make some cut somewhere. Okay. In practice, depending on how many customers you have, and so how many customers you have, and how much you want to spend on this test, and so you can make the cut. So for example, and rule of thumb, if there's a 0.8 correlation, sometimes you may want to drop the variable that has a relatively lower that has a lower predictive power. Okay, but keep the one with a relatively higher predictive power one, and in this case it will be purge. Okay, so now let's divide the customers into groups, and we start with the recency measure. Okay, and we use recency to rank our customer from best to worst, and then divide them into groups. Okay, and so here I want to divide them into 10 groups. Instead, the command is xtile. And so we have xtile, and so the command is xtile. I want to create a group number and to show to which group the customer belongs to, and that new variable, that group number, is called recdec, recency decile. And how do we create this group number? This group number, it should be measured using last, recency variable. Okay, and how many groups? 10. So n quantile 10. So we divide customers into 10 groups based on last, the recency measure, and so each person will get a group number, and that group number, we call that new column, that new variable, we call it the recdec. Okay. Next thing I want to make sure that best customer on top, worst customer at bottom. Okay. And so in this case, what I could do is I can check the mean recency across all the 10 groups, whether the most recent customer are top and the least recent customer are at the bottom. Okay, and so the command that I used here is tabstat. Tabstat last is a recency measure. The statistics that I'm particularly interested in is mean, the mean of the last. So I want the data to show this average across all groups, and so by recdec, okay, the group number based on recency. So here we can see the first group, and they are the most recent customer, and the last group and the 10th group, they are the least recent customers. Okay. The next thing that I want to take a look is the response rate for this particular book. The book, the Art History of Florence. This book's response rate. Okay, for this particular book, and the response rate for each one of these recency groups. Okay, and how do we come up with that response rate? Okay, and the variable and measuring whether the person responded or not in the data set is called buyer. If the person responded, the buyer variable will be 1. If the person didn't respond, it will be a 0. So in other words, if we calculate the mean of this buyer variable within each group, we will be able to get the response rate for each group. This is because if you think about, suppose there are 100 persons belong to the same group. There are 5 of them they bought, so there will be 5 buyers. Okay, 5 ones. Okay, and so if 5 ones and 95 zeros. So if we calculate the mean buyer, the variable, what we get is 5 divided by 100. So it's 5%. So that's the response rate for this 100 customers, the average. Okay, so that's what we're gonna do. Okay, so to get the response rate, and for each group, what I did here is I calculate the mean buyer and for each group over Excel. Over Excel is basically over all the groups. Okay, and then I draw them in a bar graph for demonstration purpose. So here we can see that in this bar graph, the height is this mean buyer variable. It also measures the response rate, and the height of the bar is the response rate for each group. So in this case, across these groups, we can see the best group, the first group, has the highest response rate. The bar is the tallest. And the worst group, the last group, has the lowest response rate, and it's has the lowest group. It's the shortest bar. Okay. All right. So next, let's do the same grouping and on perch, on frequency. So here, I use xtile command and using perch. Perch is a frequency measure to divide customer into, I want 10 groups, okay? And the new group number, and based on frequency, I call it a freq deck. And so there's one problem. And so if you take a look here, even though I asked for 10 groups, here Stata only give me 6. Why is that the case? This has to do with the nature of this frequency measure. Okay, frequency measure is basically how many times you have made the purchases. And so frequency of the number of purchases is highly discrete. Okay, and the majority of the people, they bought only once or twice, and then the remaining person bought from either from 3 times up to 12 times. Okay, and so here I asked Stata to group all these customers into 10 groups, and so we have 50,000 customers in the random sample. So if I ask Stata to divide them into 10 groups, each group I should see 5,000 customers. And so, however, here the first group, people who bought once, and so the people who bought once, there are 15,000 of them. So it's almost 3 times of the group size. And the Stata does not know, well, because they have the same number of purchases, and how to divide them into 3 groups. Stata does not know. So Stata just group them together as the first group. Okay, Stata does the same thing for the second group. Okay, and the people who bought twice, and it's also almost 15,000 customers, and that's also 3 times of the group size that we intended to be 5,000. Okay, so in this case, Stata group the people who bought twice, group them together. Okay, but because the people who bought once and bought twice, and each one of them, they are almost 3 times of the group size. So as we saw here earlier, the group index is 1,4, so 147, so which basically the first 15,000 customers, they were in the first group, okay? But there is no group 2 or group 3, and then we jump to group 4 directly. And then the next 15,000 customers were in the fourth group, and there is no group 5 or 6. We jump to 7 directly. And then Stata will try to group the remaining customers into groups and with a size as close to 5,000 as possible. Okay, so that's what Stata does. Okay, so here, one problem here that we can see here is basically, well, if we check the number of purchases, we want the best customer on top, worst customer at the bottom, remember. And here we want to check, well, whether the best customer on top, worst customer at bottom. And one problem of Excel is that the Stata will sort the data, sort the group number, and ascendingly. Here, it turns out the first group, they made the least purchase. And the bottom group, the last group, they made the most purchases. Okay, so in other words, the ranking of the groups were flipped. It's wrong. Okay, we need to flip it back. The way that we do it is, well, if we think about it, if there are 10 groups, okay, and the ordering is wrong, if we use 11 to minus whatever the group number generated by Stata, okay, and then we basically, we flip the orders, okay, and so that's exactly what we're doing, and we use the 11 minus the freak deck and to get the rank of the group number flipped back. Okay. Next thing, I want to see whether the best group, as measured by frequency, they're more likely to buy this art history of Florence. The worst group, they are least likely to buy this art history of Florence. Well, it turned out it is the case. And among these 6 freak decks, okay, among these 6 frequency groups, we see people in the first group, they have the highest response rate for this book. They have the highest bar, okay? And the last group, the worst, they're the worst customer as measured by frequency. They're least likely to buy this book, okay? And they have the shortest bar. We do the same thing for monetary. Here you can see monetary, they have exactly 10 groups. Each group has a very close group size to 5,000. Okay, this is because, well, money is more continuous than frequency. So because it's as fine as to the level of cents, okay, to the unit of cents. So that's why we can easily generate 10 groups with equal size. And so here again, and the order of the ranking is flipped. The first group and has the least spending. The last group has the greatest spending, almost $400. So here we use the same trick to flip the order of the group numbers. So we use 11 minus whatever the monetary group index generated by Stata, and we use the 11 to minus it and to flip the ordering back. So, and then we check whether the best groups, they're more likely to buy, the worst groups are least likely to buy this book. Okay, so here we can see, well, on this bar graph, and the first group, they have the highest, the tallest bar height, and which is corresponding to the response rate. And the last group has the least response rate. And so this is what we got. Okay, so this is exactly what we're looking for. All right, now let's think about how do we go from here. Okay, so by the way, in practice, most of the cases that most of them, they will use quintile analysis, 5 groups per measure. Okay, the reason why here throughout we use this 10 groups per measure, and it's because in practice some firms use a type of analysis called decile analysis, what they do is basically they go to their database, and based on their understanding about the customer, they pick a variable that they think that has a highest predictive power and can predict the customer behavior. They use that variable to divide customer into 10 groups, okay? And then use those 10 groups to decide to whom they should target a product, a campaign, so on and so forth. So what you just learned, what you just saw here is basically how to do decile analysis, okay? And however, in practice, when it comes to RFM analysis, most companies, they will use 5 groups instead of 10. And so here we have, we divide all the customers into groups based on RFM into 5 groups per measure. And so we will have 125 groups. And when we use 5 groups, when we flip the order, okay, flip the order for frequency and monetary. And earlier one in the decile analysis, we used the 11 minus whatever the index created by data. And here, because we use the quintile analysis, we will only need 6, right? Use 6 minus the use 6 minus the frequency groups index, use 6 minus monetary index, and we flip the order instead of using 11. Okay. Next thing is that we need to put the RFM, this group numbers, each group numbers together. So now we have 1 for recency, 2 for frequency, 5 for monetary. We need to put them together. How do we do that? Okay, at the end of the day, we need a 3-digit index for each customer. Okay, how do we do that? What we will do here is basically we'll use 100 times the recency measure plus 10 times the frequency measure plus the monetary measure. Okay, so in this case, 100 times 1 plus 10 times 2 plus 5. So we have 125. And so 125 will be the 3-digit RFM index for this person. Okay, and then we draw this new bar graph across all this 125 RFM index. Here we can see here, well, people we have here is basically they have different response rates across this 125 groups regarding this particular book, The Art History of Flowers. And you can see here there are a lot of some hikes and there are some dips. And that basically means, well, even if some people they're ranked low on RFM indices, and it doesn't mean they have no interest in this particular book. In particular, it could well be the case, or some lower ranked groups, they have a particular interest in this book. Okay, so in that case, as long as their rate, their response rate is higher than the break even, we should send them this offer. Okay, so there are 3 types of last thing that I want to mention is that there are several different ways to construct RF indexes to group customers. Okay, the one that we just saw is called independent, which is basically we go to the whole database and we use recency to group customers. Then we go back to the whole database. We use frequency to group customers. And last, we go to the whole database. We use M to group customers. And so that's independent, what we just saw. There's another approach called sequential. What sequential does, sequential approach is basically something like this. We go to the whole database. We group the customers into groups using the measure with the highest predictive power. In this case, it's R. Group customers based on R and from 1 through 5. And then among those people within the same recency group, and we rank them from 1 through 5 and using the frequency measure, the second best predictor. Okay? And then within those people who are in the same RF group, and so we use the we use the measurement with the least predicted power to rank customers from 1 through 5. The reason sometimes we want to use a sequential instead of independent is, if you think about it, RFM groups under the sequential approach, they are more homogeneous within group, and they are more different across groups. Take the RFM groups 331 through 335 as an example. All these people, they are on the same recency group 3, the same RF group 33. And then we rank them from 1 through 5 on the monetary measure. Okay, and so they are more homogeneous on the RF measurement. And so the downside is that, well, in this case, at the end of the day, we cannot make a comparison across group on the, say, the monetary level. And for example, if I got a person and belong to the group of 115, another person belong to the group of 551, we cannot say the second person and is a better customer on monetary than the first person, because they belong to different RF group. Okay, the first person belong to the RF group 11, the second person belong to the RF group 55, and so the ranking of the monetary are within groups. So we cannot compare the 5 and 1. And so this is the sequential group. And there is a third map. This is basically the bar chart created using the sequential grouping method. And there is a last method. It's called intuitive grouping. So this is basically forget about arbitrary divide people into 5 groups. And so I think the customers, they should be grouped into, based on their recency, they should be grouped into, say, 6 months, 7 to 12 months, 1 to 2 years, so on and so forth. Okay. On frequency, it's one-time buyer and repeat buyer. And for monetary, it's just a low dollar, high dollar. Okay. And that is the way that I think I should group our customers. So if that's the case, I don't use 5 groups or 10 groups. I just use this method to categorize customers on the 3 dimensions. Okay. And so this is called intuitive grouping. So now the next thing is that we need to think about is this break-even response rate. And so break-even response rate is basically if the customer's response rate based on my random testing is greater than this break-even, we should send this offer to that segment. And if not, we shouldn't send this offer to that segment to avoid losing money on those segments. Okay. And what is this break-even in this particular case? For this case, the cost of communicating with that consumer, with that customer is $0.50. And so if the customer made the purchase, and the price will be $18, and so the wholesale price of selling this book will be $9, and the shipping cost is $3. So the net profit upon a sale, it will be $6. So using the formula we talked about earlier, the break-even that we can get here is basically 8.3%. So whoever got a response rate higher than 8.3, we should send out this offer, and we should send out this offer to them. And whoever got the response rate lower than 8.3, and we shouldn't send out this offer. Okay. So how do we decide to whom we should target? Okay. Before we get to that, and let's first take a look at here. Right. This is the baseline, the benchmark. Okay. So the basic idea, if we don't do any targeting, we just send this offer to everybody in the remaining 500,000 customers, how much can we make? Okay. And this is how we think about this problem. We don't have information on this 500,000 customers, except we know their RFM indices. Okay. But we do know for the 50,000 customers who responded, who didn't respond. And we also know for the 50,000 customers, what are their RFM indices. So if I were to roll this offer to the remaining 500,000 customers, and I will expect the response rate should be similar to the 50,000 customer random sample, okay? Because it's a random sample, so the whatever number I got out of this 50,000 customers will be a good estimate of what would happen in the remaining 500,000 customers, okay? So here for the 50,000 customers, I sent the offer to everybody. At the end of the day, 9.04% of them they responded. So in other words, 4,522 of them they responded. So in this case, I can calculate the gross profit. Okay, so gross profit is basically $6 times the 9.04% of the remaining 500,000 customers. Okay, so 9.04% of the remaining 500,000 customers they will respond if I were to send them this offer. And the marketing cost for sending out this mail to inform the customer about this offer is $0.50 times 500,000 customers. So here I got the profit. So look at the bottom, look at the bottom line, the last line. So it gives us the return on marketing expenditure, so which is basically the profit divided by the overall marketing expenditure, which is $0.50 times 500,000 mails. So here we got the return on marketing expenditure is 8.5%. Okay, so if I were to go to do targeting, I want to send this offer to those people who are only to those people who have a response rate greater than 8.3%, the cutoff. Okay, how do we in the data? How do we generate the number? How do we generate this new column? Tell us whom we should target, whom I should not target. Okay. And so to do that, we use this command egen that we talked about during the data demonstration. So egen command is basically, egen command is basically a command. It will compute the mean, all right, and then assign that mean, compute the mean based on groups, okay, and then assign that mean to each group. Okay, let me give you a simple example. And forget about the table on the slide for the moment. So imagine there are 3 female customers, there are 2 male customers. The 3 female customers, and they spend on average $5. The three female customers, their purchases are $5, $10, $15. So the mean spending among these 3 female customers, it will be $10. And there are 2 male customers, and so they spend $4 and $8. So the average among these 2, it will be $6. So the egen command, what we will do is basically I want to calculate an average spending by gender. So I will egen average spending and equals to mean parenthesis spending, comma, by parenthesis gender. So in this case, egen will basically calculate the mean among the 3 females, which is $10. Assign this $10 to the new variable named average spending by gender, and to these 3 females. So all 3 females, they have the same $10 as this new variable value. And then for the males, the average is $6. So the egen command will calculate this $6 and then assign this 6 to these 2 male customers. Okay, and the new variable name, of course, again, is average spending by gender. Okay, so that's what we're doing here. Egen response rate and equals to mean buyer by RFM indexes. Okay, so here is basically for each RFM group, we calculate the response rate, the mean response rate, and assign that mean response rate to everybody within the same group. So for the group 111, okay, the response rate on average is 33%. So everybody belongs to the group 111. They have this 33.3% as their response rate. So we do the same thing for every one of those 125 groups. Okay? So here is this agent command. And then for those groups, as long as they have this response rate greater than 8.3%, the cutoff, we will mail them. We will target them. So here is this mail equals to 1 command. Okay, the mail equals to 1, that means this person will be targeted, and otherwise the person won't be targeted, and there will be dot in the on this new column. Okay, all right. So if we were to target customers in the remaining 500,000 customers, and whoever the response rate is greater than this cutoff 8.3%, how much can we get? So we want to make a comparison against the benchmark we calculated earlier. Okay, we don't know what would we don't know exactly what would happen in the remaining 500,000 customers, but we do know what happened for the 50,000 customers in my random sample. Okay, so and then we can use this as an estimate for the remaining 500,000 customers. We know that among these 50,000 customers in my random sample, 46.54% of them, okay, they have a response rate greater than this cutoff, 8.3%. So if I were to target it, if I did target them at the first place, I only need to mail this 46.5% of the customer. I would do the same. I would do the same for the remaining 500,000 customers if I'm doing targeting. So in other words, in the remaining 500,000 customers, I will only target 46.54% of the customers. Okay, and then among those customers that I targeted, the 46.54%, it's basically 232,680 customers, and how many of them they bought. Okay, in the 50,000 customer sample, okay, if I had targeted the 46.54% of the customer who have a high response rate, higher than the 8.3%, 14.05% of them, they responded. Okay, they bought. Okay, so in this case, well, I would know that in the remaining 500,000 customers, okay, 14.05% of them, they will buy on expectation. Okay, so with those numbers in hand, we can calculate the gross profit. Okay, and is $79,812. Okay, we can actually, and then next we can calculate the return on marketing expenditure. The marketing expenditure is actually here we save a lot of money because we didn't send out this mail to everybody. We only target less than 50% of the customer. Now we only spend $0.50 on this 46.54% of the customers, so we save a lot. As a result, the return on marketing expenditure is almost sevenfold, and so nearly 70%. And remember earlier, the return on marketing expenditure is 8.5%. Now we got almost 70. Talking about making money, here we go. So, and I did the same using the sequential approach and using the intuitive approach, okay, across the board, and every approach, as long as I'm doing some reasonable targeting, the return on marketing expenditure and will be much higher than the mass mailing. This is where we are, and as you can see here, and we not only have high profits, and more importantly, and we have much higher return on marketing expenditures. So this is where we are, and let me know if you have any questions. All right, good luck with the assignment, and I will see you next week.